Okay, welcome to the 2 days lecture about descriptives and distribution. It's actually a lecture continuing what we have discussed the last lectures. The last lecture we were going more into qualitative research and all aspects around it, into designing research. We go on with that, so I will work with a couple of examples. I will change the examples. We are not talking about crowd movements today. We are talking about entrepreneurship. Actually, my discipline, I'm professor for entrepreneurship here at TU Berlin. But my first professorship I had was in quantitative research methods, and that's actually where we start now to discuss the quantitative research methods. One announcement, we will have an additional lecture on machine learning and artificial intelligence in research instead of a summary. So we will have a next lecture about statistics and quantitative methods, then a lecture about social network analytics, and then a lecture about machine learning, artificial intelligence in research, because it's used more and more. So, but it will not be part of an examination. It's an additional lecture here, not given by me, by someone else. So, yeah, what I said, there are different qualitative and quantitative methods. And there is a trend somehow that all data which are originally qualitative can be quantified. So I can observe and I can actually quantify every picture. I can quantify interviews. I can quantify textual documents. So I can quantify records also in anthropological research. So the difference between doing really qualitative and doing really quantitative is disappearing. Even more when we speak about machine learning or methods based on algorithm, it's disappearing. And therefore, you should not see it as a contrast between quantitative and qualitative. It actually integrates into one research stream. But you still have different software for that. As I display here, you have Mexico data, Atlas for analyzing text. You have Tableau as software for analyzing photos and footages. You have Condor for going into social networks, mapping social networks, analyzing social networks, Facebook, Twitter, whatever networks you mention. And you have statistical packages. When you here at TU Berlin, you have access to qualitative software. So Atlas TI is a startup from TU Berlin. You can get the license for free. At the moment, it's a bit difficult because after the hack, not all sites are open yet. But normally you can get it for free, a license of Atlas. MaxQ data is installed and can be used at a computer pool of sociology here at TU Berlin. Yeah, why do we actually know about it? Not only entrepreneurs need to know about it. I mean, knowing about research methods enables you to distinguish somehow fake news from real news, to read real research, to interpret research. I mean, we are confronted by so many things. You just, I go to Google and type in COVID-19 research, I go to Google Scholar, I maybe find thousands of research studies all over the world, maybe even in different languages. Having knowledge about how research should be done and what's good and bad research and how to read tables enables you to distinguish really what's research I can count on and what's research that's bullshit. When you are in a situation later on working for a company, starting up yourself, and you have to do analytics yourself, it also enables you to set up a research design which is a decent research design which makes sense and leads to real relevant results. We are not going so far that you are completely capable in applying statistics or whatever, but you should have a picture what to do when you are in the situation, and you should be able to interpret research. We are not going into software here. Let's take an example which comes often at universities or in my field. Do we achieve anything when we teach entrepreneurship, or do we engage you or make you more creative when we have certain subjects? We do have the subjects, we might believe in that, but it might not work. But what makes you really, what does science say? What makes you more creative, open for other things, seeing more opportunities, and finally making you more entrepreneur? And there are three things that are well described in the literature. The first thing is your position in your own social networks. When you have a very diverse network, so when you're connected to many, many different groups, your hometown, your former school, you do music, you do sport, and you have different groups, you make party with other guys. So you have a whole diversity of network contacts, providing you with a very diverse knowledge that makes you seeing opportunities earlier, makes you more entrepreneurial, makes you more being creative. We can teach you that, whether you do or not. It's your decision, but we can explain you what would help you to actually be more creative in certain situations. And what also is well known, that this bacteria Toxoplasmose gondii, which is a bacteria 50% of all of us have, but we don't realize. But as behavioral research shows, it changes our behavior. We get less risk averse, we are more open, we think more out of the box. It makes ourselves more creative and even more entrepreneurial. There are even studies that show that people who are infected get more entrepreneurial, start more startups, are more into startups. That's a bacteria you get from cats normally. So if you have cats at home and you touch them too closely, you might get infected. It does not have any effect, at least not much. For pregnant women, it is tested because it can have some harm in a pregnancy period. Therefore, all pregnant women are tested on that. And having that, there's also a lot of empirical research done on the samples of pregnant women that are infected. Another thing is, that's the way of how you approach problems. And there are two general ways. One is causation and one is effectuation. To give you a good example, when you want to cook a meal, you invite a friend and you want to cook a nice meal. You have two approaches. One approach is to take a cookery book, look inside, and buy exactly what's in a cookery book. 200 grams of that, 300 grams of that, 3 eggs, whatever you need. Or you open your refrigerator and look what's inside, if there is something inside, and make the best out of that. The first approach would be a causation approach. I buy exactly that and I get that result. The other approach would be an effectuation approach, looking what's there and making the best out of it. And the second one rather leads to entrepreneurial outcomes and to creative outcomes than the first one. The first is a more scientific approach. The causation approach is a real scientific approach. That's not creative, but that's a decent method where we have solid results, not creative results. The entrepreneurial process is different. There, effectuation is much more common. So let's say we have this conceptual model. We have these three variables, your network position, being infected with the bacteria, or having an effectuation approach in solving problems. So for testing that, we need some data. And we really, because it's well described in the literature, we can formulate hypotheses about that. So that all is affecting creativity in a positive way. That would be our simple conceptual model. And now we have to think about data. And in the current state, we are not working only with questionnaires. I mean, working with surveys and questionnaires has become harder anyway, because people don't like to fill it in anymore and you don't get a response rate of it. So it's anyway difficult. Normally, when you do research nowadays, you might use a survey, but you also gather data next to that. For instance, the bacteria. I cannot ask you whether you are infected. I have to test that. I can do it in an experiment, so I could take blood samples now from you and see whether you have antibodies and see who is infected and who is not infected. I also could take an experiment. I bring a basket with cats with me next time and I set it here and you touch all the cats and I take a blood sample a few weeks later. All possible, but I have quantified data. I know how many of you are infected with toxoplasmosis. I don't need a questionnaire for it, that's measured. And that's a quantitative measurement. And what I get is a metric data, because it's clearly you're infected or not infected. I might even be able to measure how much you are infected, so how many antibodies you have in your blood sample. So all other things I might ask with a questionnaire. And a questionnaire nowadays is very seldomly done on paper. You do it as online questionnaires. There's many tools for that. In creating that, you can send it around by mail, but you can also use one or another tool for creating questionnaire online, sending a link, and people can fill it in. That's the normal way it is done nowadays. And there are many platforms. Also, we use nowadays this platform. Nobody is working anymore with paper questionnaire. That's past. So the first thing, that's our dependent variable, it's creativity. So it's hard to measure. It's hard to measure from an external evaluation. So if I ask other one judging the creativity of someone else, it's normally done with a self-evaluation, and that's the most easiest way to measure that. And that's also labeled in social science Likert scale. Because we cannot really measure it like the blood sample and the antibodies, we use a scale from 1 to 7 or 1 to 5 or 1 to 10 to simulate whether we would have a metric scale. Of course, that's not really metric, but we interpret it as metric and label it Likert scale to use it later as metric scale in our statistics. So I would ask you how creative you judge yourself in a scale from 1 to 7, very creative to not at all creative. So you indicate a number. Normally when you are completely insecure, you take the 3 or 4. That depends how you construct the scales. You can take a scale with 5, 7, 9 to force people to go on one or another side, but you also could take scales where there is a middle point. Like with 5, 7, 9. You could also take a scale like a 6, where people have to choose a side. But that's only a very easy thing. Normally, most variables are measured with batteries of questions. It's the same thing. We take a battery of Likert scales and ask questions. That's a battery of questions measuring lead userness. That means measuring how entrepreneurial, creative people are. And we have adapted this scale to children. So we were using that in school classes of 7, 8, 9-year-old children. And therefore, we speak about toys and that things. And that scales are later on, I will show, are tested, how valid are the scales, how reliable are the scales. So you have to test whether you measure one dimension with a scale or whether you measure different dimension. And you have many of the scales. You have very thick books out containing hundreds, thousands of scales that have been developed to everything that can be measured in psychology, sociology, business administration. That is measuring lead userness. That's a common scale, normally not using toys, but other words in that, and that's used very often. Another scale we don't need here in our small example, it's a semantic differential scale. That's often used to ask about opinion, where I have two contrasting semantic words showing people, and the people have actually to find a way within this words, good or bad, is something emotional or non-emotional. So that you have to find your way in a semantic scale from two extremes. Just to show you this example, because it's very often used in questionnaires, and it's a very common operationalization of studying opinions. You also can measure networks. So I could ask you how many times you meet someone else in the group, or how many times you communicate with someone, or how many times you send a message. And I could list your names, and yeah, you could indicate that. And out of that, I could construct a network. However, since a lot of networks or network activities are happening online and not offline anymore, I also could use a software. When I have your name, I could use a common software and search for you in social networks. When I use the user, and now the username, of course, otherwise I will not find you, and find your position in a lot of social networks. As for instance, Condor is one software you could use for that, but there's many more software you could use for that. And that's the kind of web crawling where you get in the World Wide Web into social platforms and look for network positions. That would be next to a survey. That would be also add-on to the survey. So we have the blood sample, we can go into the social networks and find the position. So not all can be done by surveys. And, many things you need many things additional data. Measuring effectuation, there are also several ways, and I show you the whole list of that because I did not want to show you only one measurement. There are several ways of measuring that, and also all the other variables here, but it's measured several times in questionnaires. And a suggestion from my side is when you construct a questionnaire, it's always good to take scales that have been validated before in research, that have shown to work. So go into the literature and about effectuation, you will find a lot of it. Take the scales others have used successfully in their research, not constructing everything yourself, because most has been constructed already, is tested already. Okay. And then we are by the data level. The most usable data level is metric. And therefore, we try to measure as many as possible metric variables. So we have the blood samples, we have the Likert scales, we have this web crawling, Condor, network position. Actually, everything can be interpreted as being metric. And that's the data level that can be used for all statistics. But sometimes you have variables that are not metric. For instance, when I have a survey, I commonly would ask you about gender. Could be male, female, diverse, whatever categories you take there. I would ask you about the level of education, which is not really a metric variable. So I have a lot of questions that are not metric, that are ordinal and nominal. But you have to know that, what's nominal and ordinal, because it plays an important role when you do apply statistics, what data level you have. Most of it is metric or interval. For that, you can use all statistics that are available, but some of the variables are only on an ordinal level or on a nominal level. Okay, when we do statistics, we normally have a very broad population, and therefore we take a sample out of this broad population and use inference statistics to conclude out of the sample to the population. And that's the sense of doing real statistics, doing quantitative research in finding a reasoning from a smaller group out of a very big group to find what's going on in a bigger group. That's very tricky. To give you one example, you all know this evaluation of courses, but you can fill in what not so many people do. When I distribute that, we have actually 61 enrolled people. I was looking it up shortly before this morning, before I came here. The result depends on how many students fill it in. Let's say I ask you how much you like this model. And on a scale, on a Likert scale from 1 to 5. You like it very much, you don't like it at all. The final mean, and 20 people fill it in, the final mean is 3. Because not all filled it in, only 30% filled it in, can I really take this mean I find in this 30% and transfer it to the entire population of you, which is 60? And therefore, I create a confidence interval in statistics to say to how much percent I'm sure that I can transfer it. And normally in statistics, you only accept a failure rate of 5%, not more. So that means I have to be sure to 95% that it is there. So having this mean of 3 in constructing lines of this 5%. You can calculate yourself. It would mean going down 0.25, going up 0.25. That would be the channel where the result is in. However, by having only 20, I cannot construct that. I only might be able to construct a 20% confidence interval. And that would mean I find a mean of 3, but the reality could be between 2 and 4. And that's for most student evaluations the case. And that's the tricky point with that, and that's the tricky point with statistics. So the relation between sample and population is very important. You also could calculate the strength of effects you are looking for on the sample size. So that's already something which is important. Another thing is important, that in research, it's often quite unknown what's the population. So people do research among startups and say, okay, I research the Berlin startups and I take a sample. The sample might be random, okay, I have 100 startups. But the difficult thing is, I don't know how many startups are in Berlin. So I don't have any information about the population. And that's also weakening what I can do with that if I don't know the population. Another thing is, how representative is the sample? Is it really a random sample, or is a sample biased? And that's often the case when I use surveys, because only certain people fill in surveys. They have their own interests or interest in the results. And by getting only the people who are interested in the results or have their own interest, I have a biased survey, a biased response rate, and I don't have a representative sample for the population. So that are all mistakes that can happen when you do statistics. Reasons for drawing a sample is clear. In many, many cases, I cannot just ask everyone. Maybe I can do it here when I have 60 students that everyone fills in the questionnaires, and I don't need statistics because I can take the mean as it is. But normally the population is much bigger, and I have to take a sample because it's more efficient, it's not so costly. I really can do that, I really can say something. And samples are quite common in research. Just look at elections. I mean, there are certain samples that are taken from people before to predict elections or to predict consumer behavior or whatever. So samples are quite common, and samples are really, when you have a representative sample, you actually can quite good predict future outcomes. It only fails when the sample is not representative for the population you want to say something. And then you have to draw a sample, and there are very different methods. You have this non-probability samples. With that, you normally don't do much statistics. That are samples when people are in front of a supermarket and ask you certain questions, or on the street ask you certain questions. That's not a random sample. That's an opinion sample, mostly done by market research institutions or other institutions to get a quick result. That's actually unusable for real research because it's a non-probability sample. Probability samples, the most easiest one, it's a completely random sample. For instance, if I take the 35,000 students of TU Berlin and I use a software getting out 100 students random, that would be a complete random sample. Or you have whatever is the social security number of all people in Germany, and you draw 1,000 people out of this random. Then you have a complete random sample. But you could be mistaken by that. It could be still biased. And therefore, sometimes you rather take a more stratified or cluster sample. For instance, when I want to say something about you as students, it might make sense not to take a random sample of all 35,000 students, but to go to the faculties and take a random sample within the faculties, so that I have all faculties represented in my final sample. Because we have very small faculties, and when I take a random sample over all students, it could be that I have a very small fraction of the students of the smaller faculties there. So when I want to say about everyone, it would maybe be good to go to the faculties, and within faculties I take a sample. That would be more a cluster sampling. I also could do it stratified, not thinking about faculties. I could think, okay, we have more male students here than female students. Maybe I take a random sample out of female students and out of male students. Or I could take a random sample out of bachelor students and of master students. So I could stratify my sample. So the only thing is, the difference between a simple random sample is that you group your population in certain, stratify it or do it in clusters, and then do a random sample out of it. But according to your research, you really have to think about it. In having the right sample in the end, you might think about certain sampling strategies. And of course, there are a lot of errors that can happen. In surveys, that's really tricky because the response rates are normally not higher than 10%. And so many surveys are biased. And for real research, these surveys are hardly usable. And you really have to check whether the survey or the sample, as a responded sample, represents the population. And in most cases, that's not the case. In market research, not in real research, I would say, what marketing research institutions do, they weight. If I don't have enough women in a sample, I give a weight to the women that are there and artificially increase the number of women in the sample. So you actually can weight and make it representative, but it's a kind of artificial method doing that. And that's not so common in science, and it's very discussed in science to do that and how to do that. It's a bit a tricky method. Yeah, that is the most common software SPSS you get here at the university. You also can buy it on internet. It's not so expensive when you have a license of 1 or 2 years or even 3 years. R is free, but requires a bit of programming skills. Not much, but you should be a bit handy with a computer doing that. HLM is hierarchical linear modeling. There's a student version for free. And Stata, if you join the Stata community, it's more or less an open source software. You can get it for free. Let's say we have a sample. I was asking whatever 100 people random from your students here. And I have a sample. The first thing, and therefore this course today is Descriptives, you have to get in the data. Because when doing statistics, it is also important to look at the distributions and how this data shape. And if I have asked this question, and I got that kind of distribution. At the first glance, what you see, there's an 8. So there must be a mistake somewhere, because the 8 shouldn't be there, because the scale was only from 1 to 7. And there's also a 0. So by calculating that and looking into that, I also see that there are some mistakes in the data file. And you have to check that, because that, of course, is leads to mistakes to analysis. The next thing, you have to look whether it's normally distributed or not. Because many statistics, the common statistics you use, are based on the assumptions that the data are normally distributed. So it's a perfect normal distribution you see here, but it's, I would say, quite okay. I will come to that. You actually can also look at numbers in determining whether it's normally distributed or not, but it looks quite okay. Then we go to network data. So I would ask you, who is a friend of whom, and create that network, which might look like that or that. And calculate, for instance, between the centrality, so the one of you who has the shortest distances in friendship to all others, I get this distribution. And that's, of course, far from being normal. So I have a slight problem here. when using normal statistics. But before I actually go into statistics, I have to check whether the data are usable for any other analysis which come later. Giving you an example, if data are not normally distributed, if data show a certain bipolar distribution, so maybe you have a lot of some people being very interested in mathematics, other people being not at all interested in mathematics. So you have actually such a distribution and not such a distribution. Calculating means in other matrix would not make sense. Calculating the mean in these circumstances would not say anything, because at the mean point there are the least people. Either you like it or you don't like it. And many distributions do not appear as normal distributions, but appear as bipolar distributions or even biased distributions. There are some biased distributions. If I calculate centralities of you all in your social media or social platforms, I would get probably, if I have enough students into that or enough people I calculated, a skewed distribution. There are very few being extremely central, having extremely many contacts, and all others have less. So I will not find a normal distribution, I get a somehow skewed distribution. So you have to look at that before you do statistics, because calculating means, comparing means, or working with any others, what comes later, only makes sense when you know how those data look like and whether there are mistakes in your data file. That's the first thing you have to check when you go into data, and that's called the descriptive part of any analytics. There are cues for that. When a variable is not normally distributed, you could take the logarithm of this variable, and then it might turn into a more normally distributed variable. But that are all tricks and solutions you have to find out. The first thing is that you look into the data. The next thing is the shape. Skewed is one thing, kurtosis is another thing. That's how peaky it is. Is it really normally distributed, or does it appear as such? Is everyone extremely in the middle and it is not distributed at all? That would mean that you have a very low variance in a variable. And then it becomes really hard to find any effects because this variable does not vary. It would be the case when I ask you about your individual creativity and you all say on a scale from 1 to 7, I'm 4. If everyone says 4, I have a very peaky distribution, but I will not find anything in statistics because you don't vary. And if I have no variance in any variables, if there are no differences, it's practically unusable for any explanation, because then I cannot explain why you are creative or not, because I cannot relate anything to it, because you're all the same. And the easiest way to look at kurtosis and skewness and distributions is when you calculate it and you look at the statistics. You can actually calculate skewness and kurtosis in numbers. And if that numbers are higher than minus or plus 1, you have a problem in kurtosis or skewness. If not, you don't have any problem. And we see centrality, we have a slight problem because it's higher than 1. In this case, what I said, I would use an algorithmic solution and taking a logarithmus over the variable and getting the variable normally distributed. But that needs to be tested. It's not for sure that it works, but it might work. Another thing is looking for outliers. At certain variables, you have indications that are so strangely different to any other indications, you might take them out. There are also statistics for analyzing for outliers. But what needs to be done before you do any analytics is to go really into the data and to check whether the data I have are usable for the statistics I want to use. If you have scales like lead userness, you need to do another step. You need to find out, before you summarize the scales, you can edit up the scales or put them together. So there are many methods of making one scale out of it. That's not a problem. But first you have to find out whether these 5 questions actually measure one dimension, which should be here lead userness. And for that, you have a test called Cromber's alpha. And Cromber's alpha is actually testing whether you measure one dimension. And Cromber's alpha should always be higher than 0.6. As higher, as better, but at least 0.6. You also have an indication, oh no, you don't see it here. 0.6 is a number you have to keep in mind. When you have a scale calculated, and if Cromber's alpha is higher than 0.6, it's fine. In research, sometimes, as an add-on, you also do a confirmatory factor analysis. We don't do that here. You will find it in research articles. For your purpose and for master thesis and not really advanced research, Cromber's alpha is sufficient to know, and it should be higher than 0.6. Okay, what we had last time. You come with a theory. We had the theory now. Okay, network position. You get a diversity of information, makes you more creative, because creativity is just the recombination of existing knowledge. And as more different knowledge you have, you're able to recombine more, makes you more creative, more entrepreneurial. Next theory is the bacteria theory. It changes behavior. It somehow intervenes in the chemical processes of your brain. There are theories about it. It's not proven how it works exactly, but it is proven empirically that it works. With effectuation, when you have an effectuation approach, you're more open and out of the box for creative solutions than you have a causation approach. So we have a theoretical line, we can formulate hypotheses, we can measure independent, dependent variables, we have a conceptual model, like here. You have independent variables, sometimes you have controls. I could take controls like gender, age, what you study, where you come from, whatever as controls. I could take our independent variables, I have a dependent variable, and sometimes you have also moderating variables. What could be when we take our example here? Let's say age. As older you get, as more likely it also gets that you're infected with toxoplasmosis or something like that. But that's not important. In our research model, we don't have a moderator, we have 3 clear hypotheses. But can we really test this hypothesis? No. You never ever test this hypothesis. What you test in statistics is whether the contrary cannot be true. So you always formulate a null hypothesis next to your hypothesis. When your hypothesis is that being positioned as bridge in social networks makes you more entrepreneurial, and I can measure this bridge position as between centrality, and I can measure your individual creativity. That's your hypothesis, and you expect a positive relation between that, or maybe even a causal relation that the one leads to the other. So null hypothesis would always be there is no relation at all. That's what you test. And with that, you go into the sample and look whether you find that, the null hypothesis, not the alternative hypothesis. And if you find that it's very, very, very unlikely, lower than 5%, that your null hypothesis, that there is not anything, is true, even if that percentage, only when that percentage gets very, very small, and that's your significance, then you reject your null hypothesis and you accept your alternative hypothesis. So you never test the hypothesis you have in mind, you test the contrary. And when the contrary is extremely unlikely, then you reject the contrary and you take your alternative hypothesis. And that's what we mean with significancy. Significancy is nothing else as a likelihood calculation. I take the sample, calculate the relationship, make a correlation from A to B, and I calculate how likely that is that I find this also in the population. And if that is extremely unlikely, I reject my null hypothesis that there is no relationship and I accept my alternative hypothesis. And for that, you have different tests. You can compare groups. So I could take the scale of creativity and split it into two groups, take the numbers 1 to 3 and 4 to 7, and have two groups. One group is very creative, the other group is not at all creative. And I could test my hypothesis making t-tests and looking at group means, or if I have ordinal data at group rankings. That's one sort of test I can do. Then I would have to rephrase my hypothesis, of course, but I can do that easily and use this test. Chi-square is a general test often used because you can use them for all variables. It just looks at the distribution of variables and whether there is any relationship between them. It's not going into groups, it's just showing is there a relationship or not. The next lecture we will go into all these tests. Then you have correlation, and correlation tests whether there is a negative or positive correlation between two variables. Being infected, being creative, positive or negative or none. And it reaches from -1 to +1. -1 is the extreme in negative, +1 is the extreme in positive. And we have regression. And regression analysis, there it starts to be a predictive analysis. With regression, we assume a causal relationship. So I assume being infected leads to creativity. And I can predict by doing that how much of the creativity I actually can explain. And that's most often used in business because it enables you to predict future outcomes. So you assume a causality between variables which can be transported also in the future. About market developments, behaviors, weather forecasts is a good example. They also work nicely with the confidence interval. Having information and having past knowledge and theories how things developed, they actually transport hypotheses in the future and can predict whether in 5 days, 7 days, 8 days, 9 days, but the confidence interval gets bigger and bigger because the likelihood of being wrong gets bigger and bigger. And that's what you also use in regressions. And regressions show you some relationships. It could be positive, it could be nonlinear. So I'm actually into playing around a lot with nonlinear relationships because I personally believe that most relationships are not linear. It's not always when you get more from them that changes linearly. A good example is income. I mean, what research shows, your happiness does not linearly increase with income. It increases up to a certain point and then it stabilizes. It does not get more anymore by income. And that's around $67,000 a year net income. It's a lot compared to what the average is earning, but it's not massively. But from this point on, you are not getting more happy with more money. And that's with most of the things so. When you have more and more of something, you are not increasing in something. I also do not believe that this network positioning creativity is a linear relationship. It's probably a nonlinear relationship because as diversity exceeds a certain level, it's more confusing than helping you. So therefore, I think in social science, many relationships are inversely U-shaped or maybe even U-shaped. And therefore, you also can test that. And that would be more parabolic relationships that are also found very often. So and that you all can do with regressions. Whereas with correlations, you just can look at linear relationships. With t-tests or other tests, you just can compare groups. So they all have their limits. And then you have certain tests that only work on a nominal or ordinal level, or that work most. With interval or metric data, you can use all tests. But of course, you use the tests that are most appropriate on this level, like regression, correlation. But you also have correlations and regressions for ordinal data. And you even have them for nominal data. You have a sort, for instance, as binary logistic regressions, which would work for a nominal dependent variable. So for all variables you have, we have statistical solutions. Even for network data, there are particular special statistical solutions. But you have to now, before you actually make a choice what to use and how to test, you have to formulate your hypothesis, gather the data in the right way, and prepare the data and look at the data, whether they are usable in certain tests. And you also have all methods for non-normally distributed data. You can use special regressions for skewed data or data with high kurtosis. For everything there is a statistical solution, but you have to know about it before you use it. And that's done quite often wrong in research. Another tricky point in research, which is done wrong in many, many studies, is a relationship between population and sample in a lot of ways. Sometimes the data are taken from one entire organization and everyone is filling in a questionnaire. In this case, I cannot use statistics because I have a full sample. The sample in the population is the same. Why should I use statistics? The mean I calculate there, anything I calculate there, I can do a correlation there, but I don't need statistics for that. Because I don't need to calculate the likelihood that a sample represents a population when I have the entire population. And another thing is the size of the sample. If a sample size is very small compared to the population, that's often the case in medicine. Then you actually cannot transfer the results because that cannot be representative for the entire population. And your effect power, what you can actually calculate, it's not big enough to find the effects there. Another thing is the sample itself. Is it really random? If I don't know the population, like in business administration, often the case, I just send out questionnaires, I get it back, but I don't actually know what's the population. It gets very tricky, and the results are always, should be treated with caution. So that you can make many mistakes using that, and therefore a lot of rubbish is actually published, which has made one of the mistakes or many mistakes of that. And therefore you should carefully look into research where people have done a lot of effort to get it really correct on all steps of doing research. So that's so far about the lecture today, and thanks.